So we're going to look at an excellence problem, and one of the most common trig problems that we do is water wheels or Ferris wheels or whatever, because they'll plot a wave or a sine or cosine graph as you move along a wheel. So we have this problem. The London Eye and the south bank of the Thames River in London has a maximum height of 135 meters. That's if you look at the actual eye from the ground up to the very top, that's 135 meters. The other bit of information it gives us is the diameter of the actual wheel. So the actual diameter of the wheel is 120 meters. They're not the same, and there's a reason for that. And an entire rotation takes 30 minutes. So this entire rotation thing that takes 30 minutes, that's basically telling us what the period is. So immediately we know what the period is. That's 30 minutes. And we have this diameter of the wheel and the actual height. Now I want to take a look at what that actually means in relation to the water wheel itself. So I've got this graphic, and it's a very powerful graphic, and when you play it, if you watch the green seat on the bottom as we move through this, see, as this thing moves through, it creates a basic wave graph. Now let's take a look at what all this means. Now if you remember back in our question, the diameter of the wheel is 120, but the diameter of this wheel is 100. And the center part, which is this part here, the center of the circle, and remember there's symmetry above and below where the center is. So guess what? That's our line of symmetry at 50 here. That's where our center goes through. But what happens is if you move this wheel with a diameter of 100, you get to the maximum point here. And if you know that this 50 is your line of symmetry, then basically you know what your amplitude is, because your amplitude is basically, if you take a look, we draw this line in, there's our line of symmetry, and we have a wave above and below that, and we can see that this is 50 here and here. So when you know the diameter of a circle or a spinning entity, whatever it happens to be, a Ferris wheel or whatever, then basically if you know what that diameter is, and you know that what's going to happen is you've got a center in the middle of that wheel, which is 120, then you know that above and below is basically your amplitude. So by knowing the diameter of a particular circle, you know the amplitude is going to be half that diameter. So in our case, it's 120 divided by 2, which is 60. It's an amplitude of 60. For this example here, you can see that it's not 60, it's 50. Right? So if we move this, this is where it starts at the bottom, which is where most people will get on the Ferris wheel, and then it rotates through that. But at that maximum point, that's an amplitude from the line of symmetry from the center of the circle, which is, well, in this case 50, and then down 50. Okay, so I hope that that makes sense.